isolation is really the same. So let's just go ahead and isolate it first, and then see what's going on graphically. So isolating this piece, we get that by adding the 5 over on both sides. Here we have 2 steps to do. We have to add 1, and then divide by 3. So we get that x is greater than 5 or x is less than 3. Okay, alright, so we got that to be our solutions. X is greater than 5 or x is less than 3. Let's go ahead and put it into set notation because nothing's different about that. Talking about x such that x is greater than 5 or x is less than 3. So put it into set notation, and again with the tripled set, we had it in a nice format, but when it's the OR case, we're going to just have to write this whole thing out. So just keep that in mind. Now with the interval notation, it's better to sketch it first sometimes to get an idea of what's going on. So 5 and 3 are not included, so I'm going to do the open case to indicate that. You could use a paren if you want. So this piece is saying x is less than 3, so values that are less than 3 are going to the left. We're going to go that way. And then this piece here is saying x is greater than 5, which is values that are bigger than 5, so they're going to the right. Alrighty, so here we get solutions all going to the left. That'll satisfy one piece. And then here we have solutions going to the right, so that'll satisfy another inequality because we have 2 inequalities that we're working with. So this is fine because we're talking about the OR case. And another thing I want to point out is notice that, so we're coming in from left to right, describing interval. Coming from negative infinity, we hit 3. Those are all good, but notice there's like a little gap in between that happens from 3 to 5. So there's just no activity happening there, and the way we denote that with the interval notation is we use a U for union. And it's for the 2 pieces. So the U is going to go right in here between those 2 points. So U is just for union, for you to know. So talking about interval coming in from the left, negative infinity. We never include infinities. We hit 3. It's not included. Then there's an area where I get no solutions. So I'm going to use a U to indicate that. Then I start up at 5 again, not included, and then I shoot off to infinity. Alright, so we've got another OR case. Let's go ahead and isolate it. So we're going to subtract 7, both sides, get that 2x is greater than or equal to negative 18, divide the 2. Get that. See what happens on this side. Add the 2 over. Dividing by a negative is going to cause that sign to flip. Alrighty. So we get values of x that are less than or equal to negative 9, so they're going to the left. And then we get x values that are greater than or equal to negative 5, so they're going to the right. Alright, so this is what we got when we isolated, so let's go ahead and put it into set notation, which I think is great. Love set notation. So we got a brace talking about x such that this is true. So the only bummer is we have to write out this whole thing, including the OR. And then we just close off that brace to the bottom. Interval notation, let's go ahead and graph it first. So we're talking about negative 9, which is right here on the corner. It's included, so I'm going to have to shade this in. You could use a bracket if you want. They're going with the circles all day, so. This guy is also included, negative 5. So what this piece is saying is x is greater or equal to, it's greater than or equal to negative 5. Values that are greater than negative 5 go to the right. This is saying x is less than negative 9. Values that are less than negative 9 go to the left. Pretty much when it says less than, you go to the left. When it says greater than, you go to the right. So let's see here. Interval notation. So if you're coming in from the left, you're coming from negative infinity. We don't include negative infinities. Then you hit negative 9. Negative 9 is included, so we use a bracket. Notice the union section is in between negative 9 and 5, right here. So I'm going to indicate that union there, for, you don't get solutions in that area. Then we hit negative 5, included. And then we go off to infinity. And we never include infinities. That's pretty much it. Okay, so why don't you guys go ahead and try one of the OR examples, put it, isolate, then put it into set notation, interval notation, and go ahead and sketch the solution. So I'm assuming you gave that a shot. The isolation is regular. So you shouldn't be having problems with the isolation, since we've done it so much. So here we're going to divide the 3. Here we're going to divide the 4. Alrighty. This is what I got when I isolated. Alright, so that's what we got when we isolated it. Now let's go ahead and put it into set notation first. We're going to use the brace variable we're talking about, such that just write this whole thing out, including the OR, and just close off that brace. So we're done with that. Interval notation, let's sketch it first. So at negative 2 is included because I have the equal sign there. So negative 2, we filled in circle. 5 is not included, so 5 will be a hollow circle. You could use brackets or parentheses if you'd like. So this is saying x is less than negative 2. When they say less than, we're going off to negative infinity, going to the left. So this guy will go to the left. And x is greater than 5, so that's going to the right. And notice there's no activity from negative 2 all the way up until 5. So that's where union is going to happen. So coming in from the left, coming from negative infinity, don't include that. We hit negative 2, it's included, so we use a bracket. No activity all the way up until I get to 5. It's not included. And then we go off to infinity. Alright, so this is the last example. Notice it's an AND case. So the isolation, let's do that first. Let's distribute a little bit. Here we'll get, the 2's will slice off, so we just get 3 minus 3 half x plus 1 greater than 5. And let's distribute this as well. So those 5 slice off, and you just get 4 minus 4 fifth x plus 2 less than 8. Let's combine these numbers here to get 4 minus 3 half x greater than 5. Subtract the 4. Negative 3 half x is greater than 1. You could multiply both sides by a negative. So what I'm going to do is multiply both sides by a negative 2/3, multiplied by the reciprocal and the negative. So these 3's cancel, the 2's cancel, and the negatives cancel. So I just get x, and when you multiply or divide by negative, the sign flips. That's just negative 2/3 times 1. So I get that, and let's see what happened over here. The numbers will give me 6. Subtract the 6. I'm going to do the same thing, multiply by a negative 5/4, multiply by the reciprocal, and the negative. The 4's cancels, the 5's cancel, and the negatives cancel, so you get x. Did something with a negative that had to do with multiplication and division, so I'm going to flip the sign. Get a 2 on the bottom, so negative 5/2. So that took a bit of time. Alright, so this is what I got when I isolated it. I'm going to put it to set notation. Brace, talking about x such that now since this is the AND case, I could combine them in the triple set, or I could just write it out, it doesn't matter. I'm getting crooked there, but with the AND case, I could put it in the triple set, but what's important is with the OR case, you have to write it every time. But here I just chose to write it out. I could have put it in the triple set way. Okay, interval notation, it's better if you graph it first. So negative 2/3, and that's like 2.5, right? So we're just approximating with these. So let's say this is negative 1, and this is negative 2. So yeah, you can just punch that in the calculator. It's like negative 0.67 around there. So I'm just gonna a little bit more than halfway, I guess. Just put it there. Really doesn't matter. We're just approximating. And then I said that's like 2.5, right? So I'll just put that right here. Alrighty, this is saying x is less than negative 0.67, so that's going to the left. And this is saying x is greater than negative 5/2, so that's going to the right. And notice they do overlap in this area, which is right here. So the AND case always satisfies both. And there, oh, interval notation, you forgot to do that. Alrighty, so the only place that is catching my attention is in between these two, because they overlapped each other. These are not really important. So we're doing the AND case right now. So we start at negative 5/2, not included. We go all the way until we hit negative 2/3. That is also not included. Okay, so thank you. This was everything for the compound inequality video, and hope to see you next time.